Good evening, everyone, and thanks for joining us tonight. My name is Rita Ulrich, and I'll be your host tonight. I'm a member of the Wild Ones Board of Directors, and I'm also board secretary. I joined Wild Ones 7 years ago as a member of the Twin Cities, Minnesota chapter. Our webinar tonight is being hosted on YouTube Live, and you're welcome to use the chat feature during the presentation. But if you would like to hide the chat box, you can enter full screen mode. The links referenced in tonight's presentation can be found in the descriptions below the YouTube screen. We have a series of questions that were submitted during registration that we've selected from many to answer during the Q&A session after Eric's presentation. Closed captioning is available, and that can be turned on in your settings. The program is being recorded, and we will post it on the Wild Ones website and our social media channels. That link will be sent to you by email if you registered for the program, and it's also will be available on our website. So if you do have any technical problems tonight, please email support@wildones, and we've got people ready to help you. For those of you who are new to Wild Ones, we're a membership organization devoted to promoting native plants and sustainable landscaping. We carry out our mission across the nation through educational materials and programs such as this webinar. We have a Wild Ones journal. We have done native garden designs for several regions around the country. We also have a Seeds for Education grant program. At the local level, Wild Ones chapters offer programs monthly, typically speakers. Some have conferences, most have native plant sales, seed exchanges, and garden tours. We currently have 70 chapters and 22 seedlings in 27 states. The seedlings are people working to form chapters, working up to fulfilling the requirements for chartering. We hope that you take advantage of the chapters if there are any near you, and become part of the support and camaraderie that chapters provide. Wild Ones chapters are where members get their hands dirty and we learn by doing. Many of our young seedlings are actively recruiting chapter officers and planning this year's programs. So it's a good time to get involved. And even with established chapters, they often have a wealth of volunteer opportunities and activities that they would love to have your help. You can amplify your impact as part of the native plant movement by sharing your skills and enthusiasm with others. So please reach out to your local chapter and find out how you can be involved. If there isn't a chapter near you, think about starting a seedling. We'll put you in touch with other people who may be interested in your area and help you get started in the process. Program like tonight's webinar would not be possible without general support from many people like you. So please consider donating to Wild Ones. We inspire and empower people and communities across the country to transform landscapes into vibrant and essential habitat for birds, bees, bats, bears, butterflies, and all wildlife, including us. I believe that many people will join us if they know just how fundamental native plants are in addressing our most critical environmental issues, and if they have the opportunities to learn how. And that's what we do, is provide those opportunities. Tonight's presentation with Eric Fuselier on native plants for improving soil contamination is the third of our three-part green infrastructure series. The series was developed as a follow-up to Eric's initial presentation in December, and people asked for more in-depth information, so that's what we're doing. Tonight, he will be going in depth on improving soil quality and cover a wider range of native species and contaminants. And he will talk about the emerging field of Phyto Mining, an exciting new form of phytotechnology where heavy metals are reclaimed from soil for reuse. Eric Fuselier is an environmental scientist at Olson, an engineering and design firm, and he is based out of their Fayetteville, Arkansas office. He conducts environmental impact studies and works with civil engineers and landscape designers to minimize the environmental impact of the infrastructure project that they design. His background is in environmental soil and water science. He's a member of the Wild Ones National Board of Directors, and he chartered the Wild Ones Ozark chapter, and he also serves as their chapter president. Well, let's get started and learn how native plants and phytoremediation can improve soil quality. Eric, can you turn on your video and go live?
Yeah. All right. Yeah. Thank you, Rita. I appreciate that. Let me share my screen here.
All right.
Sure, share the right one. All right. How's that looking?
You got it.
All right. Thank you. Appreciate it.
Thank you. And appreciate you sharing your experience and time with us. And I think you're ready to take it away.
Yeah. Likewise, I really appreciate the opportunity to again come and speak to all of you about the two topics that are very dear to my heart: native plants and phytoremediation. This is just something I really enjoy geeking out on and learning about in my spare time, and apply it in my work and whenever I can, depending on the whatever kind of project we're working on. But yeah, and try to bring this message to the general public just to help broaden our focus. We as native plant landscapers and gardeners, there's so much more that we could be thinking about when we're deciding which species to place on the landscape. If we could think about any potential contamination that might be upstream, downstream, or nearby whatever site we're working on. Maybe we have neighbors that are using land management practices that we, really don't prefer or like. And so we decide to, use certain species to help protect the habitats that we're trying to create from these land practices. So this is where, I try to talk about which native plant species we can use to remediate environmental contaminants, which are, there regardless of whether we are aware of them, even in low quantities often. This topic for today's program, like Rita said, is going to focus on soil contamination. The other two on stormwater and outdoor air quality can be viewed on the Wild Ones YouTube channel. So with that, let's start on our journey and learn a little bit about soil contamination and how native plants can be useful when we're trying to improve this. So, why is soil important? Well, soil is a non-renewable resource. Can take over 500 years to create an inch of topsoil. That's a long time, longer than any of us live. So even though, soil is constantly being formed, it forms at such a slow rate that if we're not careful about taking care of our soil, about tending to it, making sure that it's of good quality, it will not be replaced within any of our lifetimes. So the importance for soil conservation is very strong. We learned that especially during the Dust Bowl era, and that's when the United States formed the Soil Conservation Service, which was eventually turned into the Natural Resources Conservation Service. So because they began to focus beyond soil on water as well. So it can also take 300,000 years to accumulate enough substances in a soil to make it fertile. So again, there's different components of soil. There's the mineral component, there's organic matter in the soil, there's the pore space between the mineral and organic matter that, where gases and air is located. There's soil water, the soil solution. This is where all the nutrients and other whatnot are dissolved in that soil water. Whether it's soil is saturated, that would mean that all the pore space is filled with water and it can't hold anymore. It's at what's called its carrying capacity. But sometimes the soil is not saturated and that water is just adhered onto the surface of those soil particles. And it's in that soil solution that plants, through their roots, take up the nutrients that they need to grow and do their thing. So taking care of what's in the soil and making sure that it's of good quality is not only important for us, but it's important for the plant, it's important for wildlife, and just environmental quality and future generations as well. So phytoremediation, this is a plant-based approach to environmental remediation that makes use of the ability of plants to concentrate elements and compounds from the environment and to detoxify various contaminants. So this is the point of many of these webinars. So just reintroducing that term, just in case somebody's just now joining in and maybe didn't know what phytoremediation is. So what contaminants are we going to discuss today? Well, petroleum products, a little bit of a second part from the issue or the first episode where we talked about petroleum contamination, but we're going to talk about the heavier components. We're going to talk about polychlorinated biphenyls. These are very persistent organic compounds in the environment, and also heavy metals. And we'll probably spend the most amount of time on heavy metals. All right, so let's start with petroleum products. We had mentioned in the first episode that the lighter, easier to degrade forms of petroleum like gasoline, diesel, those sorts of petroleum products are typically volatilized and they evaporate in time. And so they're a lot easier to remediate soil because a lot of times, even if you did nothing, they would eventually take care of themselves and evaporate into the atmosphere where their concentration would be much less toxic. But then there are these harder to degrade petroleum categories. They're much heavier, less mobile, and also they tend to bind to soil. So this includes polycyclic aromatic hydrocarbons, coal tar, crude oil, heating oil. These are going to be much more tricky to remediate than the lighter petroleum categories. So sources of heavy petroleum in the environment include spills, leaks, and petroleum extraction activities. Here's a photo that I took here at a project site for a previous company that I worked for, and you can see where there is a spill there on the soil. So this is an oil field where petroleum is being extracted from the ground there. So got a close-up photo here. So this is a close-up photo of the soil, and you can really see how the soil, the petroleum binds to that soil, kind of dries up, sticks to it, and kind of peeling up like these peeling layers from the top of the soil. So since these are harder to degrade, we have fewer techniques at our disposal in order to phytoremediate these types of petroleum categories. So we're looking at Phyto Degradation and Phytostimulation, mostly Phytostimulation. And that's where we're really going to be focusing on using deep-rooted grasses and perennial plants. That's where our native warm season grasses are going to be very, very helpful to us as we do this. If you give me 1 second, I'm going to pause my mic. Sorry, had somebody come in. It's kind of distracting there, but it looks like they left. All right, so Phyto Degradation. This is where pollutants are degraded and incorporated into the plant tissues and used as nutrients for that plant. So these organic contaminants are completely destroyed with this technique. When we're selecting species for Phyto Degradation, fast-growing species that produce high biomass are going to be preferred because they take up and store contaminants faster and in larger amounts than the more average size or average growth rate plant species. Phytostimulation, just to kind of give a little bit of a review. This refers to the breakdown of contaminants in the soil through microbial activity that is enhanced by the presence of the rhizosphere. What is the rhizosphere? Well, that's the area around the root zone. That's the soil in the immediate vicinity of the roots and rootlets. So, see, I have a slide. Okay, yeah, so the roots exude natural components such as sugars, alcohols, acids, and these contain organic carbon. This organic carbon, the acids contain organic carbon. These sugars, alcohols, and acids with organic carbon provide food for soil microorganisms and enhance their activity. So many of these species of microorganisms use petroleum products as their food source. Petroleum, they are hydrocarbons. They are chains with carbon, so they are often food for some. They may be toxic for some organisms, but for some species of microorganisms, they can be used as food. So microorganisms such as yeast, fungi, bacteria can utilize these harmful organic substances as nutrient sources and degrade them into less harmful substances. So when we're employing this technique, there are several different things that we need to consider. that we need to consider the root structure of the plant and the depth of those roots. So the roots need to be able to reach the contaminant, so deeper roots the better. Annuals are not going to do so well. Annuals tend to be very shallow rooted. Those roots do not go very deep. Also, the root structure is important. More fibrous roots are going to be much better at this than plants that have larger roots like tap roots. And that's because these more fibrous root systems, because they have a greater surface area, like take the plant in the photo here to the right, there's a greater surface area associated with the roots of that plant. And so therefore, there's a greater volume of soil beneath the plant that is taken up by that root zone or within the plant, or the below ground portion of that plant. And so because a greater volume of the soil is taken up by that rhizosphere, you get more microbial activity occurring in that root zone than you would with a plant that has larger roots that have less surface area and less volume of that soil taken up by those roots. So that's why the native warm season grasses are going to be, these perennial deep-rooted vegetation is going to be ideal for phytostimulation. All plants have the ability to break down petroleum contamination, but some plants are better at it than others. And keep in mind, we're talking about low to moderate levels of contamination. If we're talking about large or high concentrations of contaminants, typically plants aren't going to grow. So that's one thing we need to consider is for these types of projects, we need to, these are more suited for low to moderate levels of contamination. Another thing to consider is that this can still be an effective phytostimulation can still be happening during the winter, depending on where you are in the United States. Here we're on the part of the United States that I'm located in Arkansas. We have a lot of warm days in winter. So that soil microbial activity starts to pick back up on those warmer days. However, it does occur at a reduced rate due to the colder temperatures. This is also a much slower process overall than using phyto degradation. But whereas phyto degradation, the plant is breaking down and completely destroying the contaminant itself. With phytostimulation, it's making use of the other organisms in the soil, the microorganisms, to break down these contaminants. So what are some different techniques that we can use for soil that's contaminated with these heavier types of petroleum products? Well, degradation covers, using a species such as one of our native warm season grasses as a degradation cover, or even a degradation hedge or living fence. If you say have a field, maybe you've purchased some property and you know, at some point, you know, people used to pour motor oil along their fence lines to keep vegetation or weeds from growing. That way they wouldn't, especially if it was a fence that was way across their pasture and they knew they weren't going to get out there to weed eat. What happens when you don't maintain a fence line, it ends up getting overgrown with all kinds of undesirable species, like especially Bradford pears, for instance. So some farmers, especially more so back in the day, would pour motor oil along that fence line. So this could be an option if you wanted to replace that fence, or at least grow some of these native warm season grasses to serve as a living fence or degradation hedge. So what are some other things that we need to consider? Well, the excess carbon in soil contaminated with hydrocarbons does upset the ratio of nitrogen to phosphorus. So we want to apply fertilizer to help restore this ratio, and that will help speed up the degradation of those hydrocarbons. If we wanted to mix in some legumes, most legumes are nitrogen fixing species, meaning they can take nitrogen from the atmosphere or from the gases in the soil and exude it from their roots into the soil in a plant available form. If we mix that in with our seed mix with the warm season grasses, this could also help speed up the degradation of the hydrocarbons. All right, so what are some species that are ideal for these heavier components of petroleum? Well, that will include big blue stem, one of our native warm season grasses, shown to be effective against polycyclic aromatic hydrocarbons. Little blue stem, switchgrass, great for rain gardens. Indian grass, Blue Grama, Budalua Gracilis. I like the name of that genus, Budalua. At least that's how I've heard it pronounced. Side oats Grama, another species of Budalua. Buffalo grass, one of our native stoloniferous grasses. If you live in a dry enough area, especially in the Great Plains region, and you're looking for an alternative to a Bermuda grass lawn, buffalo grass is one of those that it spreads with stolons, just like Bermuda grass. So there has been a lot of success with using this as a lawn substitute in the regions where it grows. It does not grow very well in the part of the country I'm in, northwestern part of Arkansas and the Ozarks, but I wish it did. Prairie cordgrass. Bottlebrush grass. This is one of our native cool season grasses. If you've ever seen a bottlebrush or know what that is, you can probably tell why they call it bottlebrush grass. It's one of our wild rye, Elymus hystrix. Red fescue, one of our native fescues. And Canada wild rye, Elymus canadensis. Carpet grass favors the more southern regions of the United States, California, Texas, Florida. Western wheatgrass. Eastern gamagrass. And common rush, getting into some species that like lower areas in the landscape. This one's a little bit more of a wetland species in most parts of the country. Green bulrush, including these in an area where soil might be moist for longer periods throughout the year would be ideal. Nodding bulrush. Ovalhead sedge. Common sunflower. This is our native sunflower, Helianthus annuus. Sunflowers were used quite a bit in different phytoremediation projects over the years. I'm not sure when I look at the research, they just mentioned Helianthus annuus. It's hard to know if they're using cultivars or the native straight variety, but this is a photo I took of the common sunflower in Texas, where it is, as you can see on this map, considered a noxious species. But I think it's beautiful. Coffee weed. Black willow. Sandbar willow. Tussock sedge. Nodding bulrush. Remember, maybe I had that one already. Review these slides. Canada goldenrod. Black locust. Eastern cottonwood. Loblolly pines. This is one of the yellow pines that you see in the southeastern United States. Common hackberry. All right, so what about polychlorinated biphenyls? Well, what are polychlorinated biphenyls? And that's a mouthful, so I'm going to use the acronym that you typically see them referred to as, and that's PCBs. So with PCBs, since these are pretty hard to degrade, they're pretty persistent in the environment, but there are two techniques that have been found with certain species to be able to degrade these, and that is with phytostimulation, phyto degradation, the same two techniques that we just discussed for the heavier components of or categories of petroleum. But PCBs were banned in 1979 under the Toxic Substances Control Act. They do not break down readily once in the environment, and because of that, they are also able to travel long distances. They were once used as it's a lubricant that has a low heat transfer. So they were used for all sorts of things, transformers, capacitors, oil used in motors and hydraulic systems, fluorescent light ballasts, adhesives and tapes, especially when it comes to electronics. There's a lot of old transformers had PCBs in those. Most of those have been replaced. but there may still be some out there that have been missed or have not been replaced. But regardless, these things are used in almost anything and everything for so long that it is now they've have found that PCBs are pretty ubiquitous. They've traveled pretty much can be found anywhere. Now, here's some other uses. I was looking up here: caulking, waterproofing compounds, pesticide extenders, wood floor finishes, thermal insulation, plasticizers. So there are some modern sources, including pigments used in inks for paper and plastic products. Most of the older electronics that use PCBs have been taken out and disposed of, but there could still be some pigments and whatnot in areas where these PCBs may still be around. It's important to note that these are very hard to degrade. Phytoremediation is not a good technique for a field scale remediation of a site that is heavily contaminated with PCBs. This is just more of a these species, the more they're on the landscape, eventually, they will, help with the low levels of PCBs that are tend to be pretty ubiquitous and help with over time, helping reduce those levels. Hopefully, I don't know how long it would take given how much is out there, but let's say everything helps. So big blue stem has been shown through research to have that ability to remediate PCB contamination in soil. Prairie cordgrass, excuse me, eastern gamma grass, Canada goldenrod, stinging nettle. But you never thought that there was a good use for stinging nettle. And you notice on that map there, it shows, doesn't show it anywhere in Arkansas. And I'm not sure why that is, because I can tell you from experience, it's in Arkansas. Sandbar willow, staghorn sumac, Osage orange, silver maple, river birch, red mulberry. All right, so let's get to the heavy metals, the inorganic contaminants. These are different from the organic contaminants. Organic contaminants being, these carbon-based molecules that are made up of more than one different kind of element. Inorganic contaminants, these are basically, an inorganic element. That's the periodic table of elements. You can't break them down any further, right? Lead is lead. Iron is iron. So these heavy metals, these are inorganic. They exist as themselves in their own basic form as a element on the periodic table. So because of that, we have to rely on other types of ways to remediate soils contaminated with heavy metals. We can't rely on phytostimulation as much or phyto degradation so much just because they're not organic molecules. So the metals that we're going to be discussing today, have them listed here: cadmium, zinc, copper, lead, chromium, nickel. I had to restrict it to these just due to time constraints. There, of course, are a lot of more metals out there and a lot other research on different metals and how plant species can be used, native or non-native, to remediate soil contaminated with those metals. And I won't be speaking as much to waters contaminated with heavy metals. That would be a whole nother topic. So this is just going to focus on terrestrial plants and soil contamination. So what do we do if we can't break these down? Well, we got to extract them, right? Phytoextraction. This refers to the absorption and uptake by plants of large amounts of heavy metals from the soil and their translocation to the above ground parts. So after a suitable period, typically what you do is after the plants have pulled up these heavy metals and have translocated them into the above ground parts, you would have to harvest those plants, especially if they're herbaceous, because after the end of the growing season, and that herbaceous above ground portion goes dormant, dies, goes back, falls down, then basically you're just pulling those heavy metals up from the soil and depositing them on top, where they could be become mobile through wind erosion, soil erosion, water erosion, all kinds of other ways, or be more likely to come into contact with humans. So, or other wildlife or insects. So it's, not good just to take them out of the soil. Then you got to take it off site and see either incinerate it or compost it. And we'll talk a little bit at the very end about a new emerging field called Phyto Mining. But anyway, whenever you incinerate or compost these, the ash or the waste needs to be carefully disposed of. So you need to make sure that you follow or whatever regulations are in place in the state that you're working in. So plants that colonize metalliferous soils, and that's such a fun word, metalliferous, have evolved different physiological mechanisms that enable them to tolerate metal toxicity. And so some of these mechanisms we can actually put to use with helping to clean up some of these areas. Some species are accumulator species. They've developed these metal transport systems. So think about somebody that has accumulated their favorite record albums. They've got their favorite vinyl records there, and they've basically have a little stash. Consider each record like a little heavy metal. Then there are the hyper accumulators. These are people that are really into vinyl record collecting. So they have a pretty large collection. Well, getting a little off topic here. Anyway, I'm a vinyl record collector, so you can see I'm getting excited. But anyway, hyper accumulator species are those that have overdeveloped metal transport systems and are able to concentrate extremely high levels of metals in their tissues. And we'll go into here in a little bit how they do this. But then there are another class of plants that can live in metalliferous soils, and these are the excluder species. Think of like the minimalist. Doesn't have any records. Keeps all their music on their the iPod or their phone. It's somewhere on the cloud. So anyway, these are excluder species that take up low levels of heavy metals, regardless of the concentration levels of those heavy metals in the soil. So they're able to exist in that soil and just regardless of whatever it is, if it's high, low, medium, they're going to pretty much take up the same amounts, whatever they need. So they only take what they need, much like a minimalist. Very, very basic, doesn't need a whole lot. So things to consider. If we're going to use these hyper accumulator species or accumulator species that produce high biomass for phyto extraction. So these are ways to pull out a lot of different types of heavy metals. The hyper accumulators are going to be best for this, but there is research has shown that accumulator species that also produce a lot of biomass are going to be also effective as well. So how does it work? Well, first stage is the dissolution and absorption. The metal must dissolve into a solution that the plant roots can absorb. Like I mentioned at the beginning of the presentation, plant roots absorb nutrients through what's called the soil solution. This is the water that has a lot of different mineral and organic matter, nitrogen, all kinds of elements, nutrients, micronutrients, macronutrients dissolved into that water, and it's able to interact with the surface of the root. Chemical reactions occur, and that root's able to take in those nutrients and then use it and translocate it to the other parts as it grows. And so these metals must be able to dissolve into a solution that the plant root can absorb. The plant roots must then absorb that solution along with the heavy metal, not filter out that heavy metal. Then chelation and sequestration. This refers to the plant's ability to, this is how it protects itself from metal toxicity. The plant then surrounds that heavy metal or bonds it chemically to an organic compound. This protects it and makes that metal more mobile within the plant. So in some cases, it can also do this before the metal is absorbed by the plant's roots. So that's another essential part of this whole thing. So this whole process, it has to be protected somehow because plants are very susceptible to metal toxicity. So these hyperaccumulator species and accumulator species have developed these ways to transport these metals, to chelate them. That way or chemically bond them in such a way that they are not going to be harmed. And then transporting them from the roots to the shoots. The plant then moves that bonded metal to a location where it can be stored safely. And that plant must also adapt to any damage the metal causes during transportation and storage. So the storage of that metal is typically stored in the vacuoles of the plant cells. The physiological systems that transport and store heavy metals are the most critical in a hyperaccumulator species because heavy metals damage the plants before they are stored. So once they're able to get that heavy metal transported to where it's going to store it, then it's going to be doing a little bit better. And typically in hyperaccumulator species, these heavy metals are mostly stored in the leaves. And that's an important thing to note because if you have, say, a field scale, a large phytoremediation site with you're trying to, there's some heavy metal contamination, maybe from mining or whatever else, and you're trying to remediate this area, then you need to consider herbivory. You don't want deer, other wildlife getting in there and eating these plants because that's going to have a toxic effect on them as well. So typically putting up fences, something like that around there to keep the deer and other herbivores out, or omnivores that might eat the plant leaves. So that's restricting access to these areas is important. Now, that's mostly going to be related to these larger scale remediation sites. And we'll go over here a little bit how we can prevent bioavailability of some of these metals as well. So design techniques for phyto extraction. This includes extraction plots. Like I just mentioned, having a big plot where you're growing plants that are extracting those metals, and you go through and you harvest the above ground portions, especially if it's herbaceous species. Then you're going to haul it off site and dispose of it somehow, whether that be incinerating, composting, or whatnot. This is a great technique for nickel. Nickel, there's been a lot of success, really easy to remediate, really easy to extract nickel from the soil. However, for cadmium and zinc, it can be a very slow process. It can be done, but depending on the levels of contamination, this could take a long time, decades, even centuries, is estimated based on the rates that they're a little bit harder to get out of the soil. Then there's phytostabilization. What is phytostabilization? This is different than phyto extraction, right? This is using the plants to immobilize those contaminants in the soil through either adsorption onto the roots of a plant or binding that metal to a soil particle in the root zone. This basically is a goal for long-term stabilization and containment of the containment of the pollutant by sequestering it in the soil around the roots and not in the plant tissues. It's important to note here that this does not remove the contaminant for the site. What it does is it immobilizes it, it stabilizes it, and makes it unavailable for entry into the food chain. So plants can also excrete substance that produces a chemical reaction that converts that heavy metal into a less toxic form. So this is another form of phytostabilization. And so remember, I talked about the different species, the accumulators and hyperaccumulators. Well, this is where our excluder species come in handy. These are great for phytostabilization projects. These minimalists, they need a minimal amount of heavy metals, and they're able to ensure that they don't take any more than they need. So stabilization mats, having some sort of vegetation cover is going to be more ideal for a field scale remediation project for the harder to extract heavy metals such as chromium, copper, and lead. Chromium, copper, and lead are all very difficult to extract. Zinc and cadmium, this would work for those heavy metals as well. So let's talk about each of the individual metals. Cadmium. Remember, this is a little bit, it's difficult, moderately difficult to extract. We can use phyto extraction for this metal, but we can also use phytostabilization. Sources of cadmium in the environment can include fertilizer, sewage sludge, especially if you have like biosolids being applied to a field, nickel cadmium batteries, pigment production, plastic stabilizers, metal plating, smelting operations. So if we're going to try to remediate cadmium, like I said, we can use phyto extraction. This would work for low levels of contamination because when those cadmium concentrations are too high, plant growth is typically going to be inhibited. And it's hard to phytoremediate something if you can't grow plants, right? Plants are pretty much the centerpiece of a phytoremediation project. So you can't have too high levels of cadmium for this to work. That kind of works out in a way just because, you know, it's a slow process as well. Like I mentioned, very slow, can take decades or centuries. Cadmium also has a high bioavailability. If the cadmium levels in the soil are high enough to where it's concern for wildlife, we can use phyto extraction just to help remove it from the area so that way it doesn't enter the food chain. So that's one beneficial use, even though it takes a long time to remediate it completely. If we're trying to get it out of there, if it's a particularly sensitive area for wildlife, then phyto extraction could be useful for cadmium. Now, phytostabilization, this is where we can make use of these large accumulator species that are used for biomass production. And I'm speaking specifically about woody species. These like willows, poplars, these are going to sequester that cadmium into their woody biomass. So willows and poplars, we're growing these species and these are accumulators of cadmium. So they can be used for phytostabilization in the sense that they are sequestering it. All right, so if we're going to use extraction, and remember this takes a long time to completely extract all the cadmium, but it is also could be beneficial in certain situations. Switchgrass is a hyperaccumulator of cadmium. Sunflowers, or Helianthus annuus, is an accumulator. Jerusalem artichoke is an accumulator. Common yarrow, also an accumulator. Dog fennel is an accumulator. Canadian horseweed, this is like one of those heavy metal rock stars. You see it pop up time and time again with the heavy metals. I mean, it seems to be able to extract almost most of the heavy metals I read about. So, I mean, I like to call this the heavy metal rock star because it is just, you know, banging it out, doing such a great job out there, pulling those heavy metals out of the soil. Rattlebush. Fox sedge is accumulator. Deciduous holly, also an accumulator. American holly. This would, you know, accumulate it and potentially sequester it. So this could be also considered a form of phytostabilization. And then black willow, one of our native willows, we can use these for biomass production, sequester it, use it for phytostabilization. Now, I'd like to take a moment to mention that oftentimes the willows and poplars that are used for these projects are hybrids. They will take one of our native willows and hybridize it with a non-native willow, and so it's effectively sterile. This is beneficial for these projects because you know, it's not going to be producing flowers that have any sort of attraction for pollinating insects or anything like that. So that's one of the benefits by using some of these hybrids. But I believe it's Southern University of New York where they're doing research on this, and I've talked to some folks up in Minnesota that use these hybrids for biomass production and whatnot. So it is being used. I don't know how much research has been done on other kinds of willows and poplars that we have growing here in the United States. So this section here and for a few of the other heavy metals, I mostly just want to bring your awareness to the different willows and poplars that we have here in hopes that somebody will decide to pick this up in an academic or university setting and want to look at, you know, potential other hybrids for other parts of the country. My understanding with the hybrids coming out of the University of New York, you know, these are going to be mostly used in the Eastern United States. But we do have other willow and poplar species, so such as black willow, sandbar willow, peach leaf willow, narrowleaf willow, the western species, prairie willow, Cooler's willow. Hope I said that right. Balsam poplar. Getting into some of our native poplars here. Big tooth aspen. Our aspens are in the poplar genus. Quaking aspen. And then here is a cadmium excluder species. So this is another potential to use this for phytostabilization as like a vegetation mat, tufted hairgrass. All right, zinc. Sources of zinc in the environment include smelting operations, mining, steel production and galvanization, metal roofing, paneling, and including tire dust and debris. That's another thing is, as we drive our cars around, that rubber does contain zinc, and we're shaving off little bits of tire as we drive it around on those hard surface roads or gravel roads. And so that tire dust ends up on roadsides and everywhere else and gets blown around. And that is a source of zinc in the environment. So to phytoremediate zinc, phyto extraction, this is used again like cadmium for low levels of contamination because again, like cadmium, when zinc concentrations are too high, plant growth is inhibited. And so phytoremediation is then not an option. It's again, like cadmium, it takes very slow. It's a very slow process, can take many, many years, decades, or centuries. It also has a high bioavailability. So like cadmium, we could potentially use phyto extraction in situations where an ecosystem might be particularly sensitive to those zinc concentrations, and we're trying to get them out of there. Also, zinc is a micronutrient for plants. So phytometabolism is another option. This is where the plant takes it up the zinc and incorporates it into its plant tissue. It's different than, say, phyto degradation, which completely destroys a contaminant and typically is applied to a organic contaminant. Phytometabolism is where it's not so much destroying it, it is using it. And then again, phytostabilization. This is where we're using excluder species or large accumulator species that can sequester the zinc. Again, Canadian horseweed, that heavy metal rock star. I never had so much appreciation for this plant until I found out what it can do with those heavy metals. And I mean, it's generally considered a noxious species. There's nothing particularly attractive about it, but you can have a whole new appreciation once you realize that it is in fact a heavy metal rock star. Side oats grama is an accumulator species. Sunflower, another accumulator species. Eastern gamma grass, an accumulator. And then again, the willows and poplars. Again, I really want to emphasize that, typically what's used are the hybrid species that are sterile and don't, produce flowers, pollen, whatnot. And so, but for research, we're trying to stimulate, in the interest of hoping to stimulate research, using some of the other species around the country. I'd like to go through and just list many of our willow and poplar species that are common to the United States, and it's the same ones. Also red fescue for zinc, it's a phyto excluder. So red fescue in parts of the country where it grows, such as up in the New England or Western United States, could potentially be used as a vegetation cover or vegetation mat. Also, California poppies or an excluder of zinc. So again, this could be used for phytostabilization. All right, what about copper? What are sources of copper in the environment? Well, this could include wire production, pipe production, electronics, even pesticides. Some of these have copper in those organic contaminants. When they break down, they leave copper in agricultural fields, and as well as smelting operations. So again, copper is a micronutrient, just like zinc. So we can use it just like with phytometabolism, same way we could do with zinc. And then again, phytostabilization. Phytoextraction of copper is moderately difficult, not as very feasible for field scale remediation projects. So, but if in places where we want to prevent it from getting out, we could use phyto extraction, but at a with the understanding that it's not really going to be remediating it anytime soon. But Pell Smartweed is a hyperaccumulator of copper. Little blue stem, an accumulator. And so it could be taking it up, and also what it can use, metabolizing it. It is a micronutrient. Big blue stem. Side oats, Grama. Sunflower, accumulator. Fox sedge, an accumulator. False indigo bush, also an accumulator. And then black willows. Red fescue is also an excluder of copper, just like zinc. So this would be great for a vegetation cover. Tufted hairgrass, we saw as an excluder of cadmium, is also an excluder of copper. Oh, kind of went back there. All right, lead. Lead it's in the environment. Of course, it used to be in the ground. Now there's much more of it above ground. Previously, past uses, it was in lead-based paints before it was banned in 1978. It was in lead pipes and plumbing fixtures before they released the new ones. No longer contain it after 1986 when that was banned. But as we're aware, there are still many old buildings and areas and parts of the country that still have lead pipes and plumbing fixtures. Leaded gasoline, before 1996 when it was banned, they found that roadsides can often be contaminated with lead if there have been they have traffic before the ban on leaded gasoline. Think about vehicles that have dripping various gas or diesel or whatnot, and then runoff runs off into the roadside or from a parking lot. That lead stays, it's pretty heavy, it stays pretty immobilized in the soil there. Also, it can volatilize and exhaust. So vehicle exhaust is another way that it can enter the environment and then settle onto the soil. Traffic cops in New York City were exposed to breathing in fumes from exhaust from leaded gasoline. Current sources include industrial facilities, batteries, and ammunition. Lead ammunition, especially shotgun. It's cheaper, so there are hunters that still buy the cheaper lead-based shot for the shotgun. They go waterfowl hunting, they shoot, and then those lead shots fall down to the wetlands, into the water, and then over time you're going to get some lead contamination eventually in the bottom of that wetland. All right, so again, phyto extraction is difficult for lead, not ideal for a field scale project, but we can use phytostabilization. Also, something to consider is chelator assisted phytoremediation with lead is something that is often done. Lead is not present in a soluble form in soil, so it is not easily absorbed by plant roots. So that's where you can add a chelator to the soil. One example, one that's commonly used, is EDTA. And this, helps chelate it, surrounds it, and makes it, and it combines it into a form that plant can then take up and move throughout the plant. So this increases the accumulation of lead and the translocation of that lead from the roots to the shoots. However, word of warning, I got that slide here coming up. First, let's just talk about some hyperaccumulator species of lead include switchgrass, pale smartweed, annual ragweed, one you might not have as much appreciation for until you realize that it is a hyperaccumulator of lead. Rough bent grass. Side oats, Grama is an accumulator. Fox sedge. Thing to consider with chelator assisted phytoremediation is this is an expensive option. It does cost money, not cheap. And to do this with caution, not only are you making it where it is able to mobilize, but it will also could easily leach into the groundwater, the water table. So it could be that you go back and you test your soil and you realize, oh, the lead's gone. I must have taken it all up in the plants. But really what's happening is it leached down into the groundwater and made your problem worse. Now that lead is maybe even migrated off site, and who knows where it went at that point. I believe there was some studies done with sunflowers where they were trying to remediate lead contaminated soil, and that was a mistaken conclusion of that study, as they thought that the sunflowers were pulling up the lead, but they found out what happened is that the lead actually migrated further down into the groundwater and off-site from there. It's better to use a lead excluder species as a ground cover for phytostabilization. We can also phytostabilize lead with amendments. Lead is bound by organic matter, iron oxides, and clay, so we can add these to the soil to help bind it up. Phosphate reacts with lead to create a new compound that's very unavailable for uptake by plants. This is just going to keep it there. And as long as you have enough vegetation, you prevent humans, wildlife, anything from coming into contact with it, at least above ground. So if you can mend the soil with phosphate, limestone, organic matter, sometimes this can help out. Chromium. All right, sources include dyes, paints, leather tanning, automotive industry, and pressure-treated lumber. Then again, chromium is very difficult to extract, so phytoextraction is not a feasible option. Here we want to rely on phytostabilization. So we're looking at excluder species, and again, tufted hairgrass is an excluder of chromium. All right, nickel. Now this is where we have a lot more hope. Sources of nickel include the burning of fossil fuels, battery production, stainless steel production, windblown dust from industrial areas, mining, just a few sources in the environment of nickel. Nickel has high bioavailability, so phytoextraction could be used whenever it presents a danger to entering the food chain from a heavily contaminated site. It's also good because phytoextraction is very easily done with nickel. Some species that are hyperaccumulators of nickel include black locust, black willow. Red fescue is an excluder of nickel, but also because it's so easily to extract, it can be an efficient technique for field scale remediation products and for phyto mining. What is phyto mining? And this is where I get really excited. Well, phyto mining, this is the production of a crop of metal, by growing high biomass plants that accumulate those metal concentrations. So it's like a green alternative to existing environmentally destructive open cast mining practices. Holds potential for the extraction of ore bodies that are uneconomic to mine by conventional methods. So when we have a heavily contaminated site, especially if it's nickel or other metals, depending on the metal, I'll talk a little bit about a few here in a little bit where they found that has been an effective way to extract them. It could be potentially a way to then reclaim these metals, pull them out of the soil from the plants, and then you'd have to harvest those plants. Another term you might see referred to as agromining. Basically, you're growing plants because of the metals that they extract from the soil, and then you can process those plants to reclaim and reuse those metals. Again, we'd want to use hyperaccumulator and accumulator species. Much of the research that I've seen done has been using non-native species. I haven't been able to find successful research with native species, but it seems like Brassica genus, the mustards, or is it the Brassica family? But usually typically like Indian mustard, not a native mustard, native to Asia, I would imagine. Has been used and has been very successful with phyto mining of nickel. But I do just in the hopes of stimulating maybe some academic research on some of our native hyperaccumulator species that we have here that are known to pull up lots of nickel. Perhaps there is some potential here for using some of these for phyto mining of nickel. So I'm just going to list some hyperaccumulators of nickel. Keep in mind, these can also be used for general phyto extraction as well. So balsam groundsel, one of our Pachyra species. Again, that heavy metal rock star, Canadian horseweed, keeps popping back up. Sunflower, dog fennel, accumulator. So, phyto mining techniques. This is, we can, in addition to the relying solely on the plants, the uptake of metals can also be induced with a chelator, another agent. We can add that to the soil, increase that metal solubility or mobilization so that the plant can absorb it more easily. Like I said, we need to see more research in this. It's kind of a new field. I have seen some research that has proves to be hopeful for iron, as well as some of our what we call noble metals like silver, gold, platinum, iridium, rhodium, thallium. But wouldn't it be nice to be able to mine gold instead of having to go dig it out of the ground? So, I mean, mining as in agromining or phyto mining, so something to think about. And with that, I'll conclude my presentation and take the questions that were selected.
Well, thank you so much, Eric. I feel like I really should have majored in chemistry, but honestly, I sucked at it.
I'll be honest, it was challenging for me too. So, yeah, it's not easy. It takes a special person to be really good at chemistry.
I think absolutely. My dad was a chemical engineer, worked on adhesives, by the way.
Oh.
But it didn't rub off on me. So, yeah, thanks for that. Before we start the Q&A, I just want to let people know that there is a link to our survey, and we do want you to fill that out after tonight's presentation. Your feedback helps us keep improving, and we also will email that to everyone who registered for the event. So I'm looking at my questions here, and one thing we could start with, Eric, is a question: how do I know if my soil in my yard is contaminated?
Right, and that's a lot of times you'll need to go to an environmental testing lab, provide a sample, would cost you money, and there are universities that do typical soil testing. Many states have these, but they typically are only going to tell you your levels of nutrients, pH, more of what you need to know for growing a garden or crops or whatnot. If you're looking for actual contaminants, breakdown of what's in that soil, if you go to Google and type in environmental testing lab near me, there are often these labs around, and some universities will also test for contaminants as well. Just kind of look up your nearest university and see if they have a soil or water lab, or they provide that service. Here, the University of Arkansas takes soil and water samples, or at least water samples, I know, to test for various contaminants, but it does cost a fee. But environmental testing lab are typically what we rely on if we are doing a remediation project, or if we're doing what's called a phase 1 or 2 environmental site assessment, where we know there's some contamination and we're trying to figure out how far has that contamination spread. We got to go out and take soil samples and see how far has it gone, or if we're looking at groundwater, they got to take samples down there, but then we send those off to a local environmental testing lab, and they give us the results.
Right. So there's no easy way or inexpensive way to do this.
Right. Yeah. Not that I'm aware of.
Okay. A lot of people have concerns about safety and contaminated soil. So several questions talked about what effect contamination has on growing food, and even native plants that are used in conjunction with gardens and farming, sometimes for the pollinator services.
Sure. Yeah. I mean, especially with heavy metals, growing food, depending on the type of food, could be an issue. Biosolids is one way that that some cities manage their waste from the wastewater treatment plants. They basically take a lot of the waste, and it's dried out, and then you'll need like to apply it somewhere to like a field but they've looked into, if you're applying it to a field that's used for agricultural purposes, it's going to depend a lot on what you're growing there. If you're growing potatoes or root plants, things like that, it's not going to be so great. There are different regulations if you go into the EPA's website on when and how much of these biosolids can be applied to these agricultural fields, depending on the crop that's being grown for food. So different plants will accumulate different, parts and different parts of the plant. So if you're basically harvesting the parts of the above ground part, there are ways that it can be applied, certain levels, certain timing of the year, that sort of thing that can make that safe agriculturally. I just remember I did a big report on that when I was in school for one of my projects, and just got really deep into all of that. But another thing to consider is foragers. Myself and a lot of people around the country are foraging wild plants, and it's not our grandparents' environment or not our great grandparents' environment anymore. That was, much more safe, several hundred years ago. Now we brought a lot of elements from deep within the earth to the surface, and so we use them in all kinds of ways, and they get spread around and put on top of the surface of the earth in various places. So I think it's important, if you're foraging root plants or from certain areas, to be aware of where are you foraging from. Cattails from an isolated pond, with nothing upstream or uphill or anything like that, out in the country, it's probably going to be safe compared to cattails in an urban stream or urban area or downstream of a large metropolitan area. It's probably going to be more likely to have lead in those roots and tubers. So just something to consider. Goldenrod, another one that people make tea with the leaves for. It can be used as a diuretic, help with urinary tract infections, all kinds of things. It's also a hyperaccumulator of lead. That lead does accumulate in those leaves. So depending on where you're collecting goldenrod from, it could be, potentially contaminated.
Wow, it's kind of scary.
Yeah, I mean, they looked at just black tea that's on the market and have found that a lot of black teas have levels of metals in them. I mean, it's a different world.
Yeah. I'm going to say it again. That's scary.
Yeah. I think it's, low enough that where it's not easily detected. It's not obvious, but you think about what persistent exposure might do over our lifetimes.
Precisely. Yeah. And there was a question about foraging and how to consider what's safe. And they reference things like an irrigation ditch. But to what degree do contaminants get into fruit, berries, the flowers and berries?
Yeah, they can. Heavy metals. Now I was looking into this just recently because I've been really curious, like what impact might this have on insects and insect populations, or if you have a field scale remediation site, what impact might that have on insects? And nectar, the metals levels can be high in nectar. One study I found was hopeful. It looked at different pollinator control group and a group where they were intentionally putting more metals into that nectar, treating the plant in such a way that the nectar metal contents were high. And they found that insects, while they would visit those flowers with the high levels of metals in the nectar, didn't spend much time there. They seemed to be able to, like, oh, this doesn't taste good, and so they weren't taking that nectar as much from those flowers. So it seemed to have a negative response in a good way. When I say negative response, meaning that they didn't prefer those. Now, the flip side of that is, is that making flowers all over just less desirable, depending on where you are in an urban area. They might just have no other choice. So while they may not prefer it, they could still be getting those, but it could have impacts on insect populations. I've read studies where they were looking at lead entering into beehives, honeybee hives, and through the lead that was in the nectar and the flowers, the honeybees were harvesting nectar and pollen from. So,
Right.
and how that, might have an impact on honey, the honey market. So, I mean, I know honeybees are, you could argue are not great for our native bees or native pollinators, but something else, it just goes to show that these metals can end up other parts of the environment that way as well, and even in our
Yeah.
foods.
Yeah, and that was another area that where you once it gets into insects, it's going to move up the food chain and presumably accumulate as well.
Right. And, I think that's really where, when it comes to heavy metals, trying to stabilize it to prevent it from entering the food chain is going to be a better option. And using excluder species in areas where, that contamination might be a little high. And there's probably research out there, tried to do some searching for some native species. I mean, there's all kinds of lists of species of excluder species, but I tend to focus on the natives. And so, I included the ones that I was able to identify in this talk, but I'm always looking for more. So that's definitely, I think, something that we need to focus on.
Right. Do you know anything about contamination, PFAs?
I don't know so much about that. I know that I've seen literature out there about it. I haven't taken the dive into that contaminant at this point. So,
Okay.
yeah, I'm not really able to talk a whole lot about PFAs.
A really good question on the phyto mining is what time frame is associated with phytoremediation and who's carrying out the recovery of heavy metals? And is it potentially income generating for a heavily polluted site?
Yeah, it can be, depending on the metal. Like I said, they've had the most success with nickel. Because, not only do you have to be able to extract it, like I mentioned, some metals are very difficult to extract. Some of them are much easier. So the much easier ones, you're going to have a lot easier time getting, but you also have to be able to extract enough to make it economically viable. So that's the other thing. So that's, where nickel combined with certain species like Indian mustard and other brassicas has shown to, have some economic viability. Then as far as disposing of it, I think, I imagine you have some sort of contractor that's, working with that's, able to do all that. I've never had the luxury or opportunity to be part of a phyto mining project, but one of my coworkers here at Olson has. So, but I think he said he was more involved on the front end with getting the plants established and didn't get to see the final result.
Okay. There are a couple questions about pesticides in runoff and also aerosolizing and then dropping, but particularly Roundup was mentioned.
Yeah, and my understanding of Roundup is that it's not soil active. When it's sprayed onto a plant on the above ground portion, it kills that plant. Once it's in the soil, it's not harmful to the soil organisms. Also, my understanding is it breaks down pretty quickly, and so in an area where it's been used, it has a short half-life comparably or relatively. Very different from many of the pesticides that we used, before Rachel Carson's Silent Spring, that were much more persistent in the environment. So, my understanding with Roundup is if you spray it in a garden area where you're going to be growing food, you can typically be growing there that same year if you plant within several weeks, and it's going to be pretty safe.
Okay. This question I thought was kind of interesting. Is there any research that you know of on the impact of artificial turf on surrounding soils?
Yeah, that is interesting. I'd have to see what those are made of. I'd imagine some sort of polymer of some kind. As far as what they are leaching, I don't know if they contribute microplastics. You hear about, and they just recently discovered microplastics in human blood. This is a new contaminant we're going to have to deal with. What impact is that going to have on our hormones? So it's just Again, it's not our grandparents' world anymore.
It really isn't.
And we don't know what we're doing until often it's too late. Like with
Yeah, and
PCBs and asbestos was like a miracle substance, right, for what it was used for until we realized, the issues it was causing. Same with PCBs, it's great, a lubricant with low heat transfer. This is awesome. Let's put it in all of our electronics and stuff. And then we realize, oh, wait a minute, no, wasn't such a great idea. There's these, bad side effects that we're now, having to deal with.
I think we have a long history of being a little too quick.
Yep.
On some things, because yeah, there are always side effects of one kind or another, and so thinking about what they might be and doing the research, but yeah, we like to get things out there fast on the market.
Right. Yeah, it's like they try to have that balance between, well, how much research is enough, how much is not enough. How much you could spend tons of money on research to where by the time you're done, you lost so much money on that. Then by selling the product, you're not going to make that up. So it's just a balance there. And, I'm glad there are certain rules in place before products can enter the market that they have to look into it. But then, I think there's continued research that's still needed to make sure that those unintended side effects aren't occurring. Whenever as a society we adopted the automobile, we probably at that time didn't realize that we'd be, losing thousands of people to these things every year. How many people die in car crashes? That's just, an unintended side effect that we just live with.
True. There were a couple questions that ask about pollinators and other insects that are on plants that might be absorbing. And now you did mention that they may not like the
according to the one study. Yeah.
It's obviously very nascent, the research on this, and much more needs to be done. So would very much like to see it. I have to completely agree with that take, because the potential is very promising.
Mm-hmm. Yeah, I agree. I mean, I don't know how much of it is this. I haven't found the research yet because I'm just, very recently within the last several months or year have been looking into that, but, only when I have time here and there. So, if anyone is aware of research, please send it. That's definitely something I want to know more about. But if the research isn't quite there yet, then it's definitely an area I think too that needs to be looked into.
Right. Well, do you want me to throw any more of these at you? One question talked about arsenic. I don't think.
Yeah, and that one is more going to be. You see that a lot more in water. Groundwater contamination. I remember, maybe 10 years ago, there was concern with arsenic in rice fields, and rice absorbing arsenic, and then our rice on market having high arsenic levels, and that supposedly, my understanding when talking with some folks at our local Natural Resources Conservation Service office, that's been an ongoing issue. It's arsenic in rice. So, yeah, and I think my understanding with arsenic is it's more mobile in water, and it's more of a groundwater issue. So I didn't really include it here in the soil talk.
Yeah.
Like selenium is another one. You see it, it bioaccumulates in fish. So, one thing that environmental consulting firms do is they go do selenium surveys of fish and take tissue samples and, test for those levels to see if the selenium levels in that stream are high, or if they're within the levels that are, good for aquatic ecosystems.
Right. Yeah, I mean, obviously, a certain amount of these is naturally occurring without having been artificially introduced.
Sure. Yeah.
Okay. One person said that he had soil tested with high aluminum, and he used his bed. But is there something he can plant to remove aluminum from his soil?
That's a really good question. And this kind of leads into another thing is, with aluminum soil, you can get an effect called aluminum hydrolysis, and that is where the aluminum and the water, the H2O, has a reaction to where it has a chemical reaction to where a byproduct that is these free hydrogen atoms, and so that will drop the pH of a soil pretty quickly through that aluminum hydrolysis reaction. And so pH of aluminum contaminated soils tends to be much lower, but then that kind of leads into another thing where a lot of these different metals and nutrients, especially the metals that are nutrients, micronutrients, are typically only plant available within certain pH ranges. So that's another way that you could look at potentially preventing some of these metals from getting into plants is by controlling the pH of that soil. So keeping it at a level to where plants it's not going to be available to the plants. But then, that might not be ideal for a garden setting where you want the soil at a certain pH to grow, vegetables. But yeah, with something that's going to take up a lot of aluminum, I mean, there probably is. I don't know if I see iron and aluminum are two that I haven't really started compiling a list yet. I've been focusing on some of those other metals, but yeah, that's interesting. I would like to learn more about which plants might be pulling those up, or how easy it is to extract aluminum, or if it's better to try to stabilize it.
Yeah. Well, speaking of a question on creosote, that a community that lives close to what used to be the largest creosote plant in the country for most of the 20th century, and the EPA cleaned it up and said it's clean, but the neighbors aren't particularly satisfied and they want their yards tested more. But the question boils down to what could be planted to help remove those toxins?
And I think that's where you're going to look at phytostimulation and deep-rooted fibrous root systems, native warm season grasses, the big four, especially big blue stem, little blue stem, Indian grass, and switchgrass are going to be really good, helpful.
Good. Thanks. And just checking. Oh yes, another situation was a buried oil tank that, because the tank had been removed, but it had been very old and had disintegrated. So clearly there was some leakage. Mm-hmm. And they said the soil assessment was good, but this spring, grass and the plantings in that area all died. So he's looking for the best way to potentially heal that.
Yeah.
Without, as it says, sending new plant soldiers to an untimely death.
Oh, yeah.
Yeah.
Yeah. It's disheartening when you plant something and it just, they don't do well. Plants are people too,
Right.
Yeah, I mean, I feel that way. We're starting to learn in science more and more, that, communication and intelligence isn't just limited to humans or animals, that, other life forms seem to have it as well. But without knowing what was in that tank, it's hard to give some recommendations. If that happens a lot with underground storage tanks, they corrode over time, and so you see this a lot with older gas stations. Right. They have to replace those tanks after 30 to 50 years, and so it's not an uncommon thing. So it just depends on what was in it. Without knowing the site conditions, to know, what other factors may be involved, but also just, you could pay for, take a soil sample and try to get it tested in an environmental testing lab and, see what may be in that soil, could shed some light on what the issue is.
Yeah. If people are interested in pursuing, well, first of all, specific information for their situations, where should they be looking?
Oh, that's a good question. This is because it's there's all kinds of books out there on what native plants we should choose for, pollinators. And there's most of the literature on phytoremediation is academic. I will tell you a really great book I highly recommend. This is just for landscape design. I don't know if you could see this. Am I showing that? I don't see my screen.
Let your pull it back a little bit because, and give your camera
Okay.
time to focus.
Put my hand here. There we go. Is it doing it? It's Fido is the name of it.
You better read it for us. Yeah.
Okay. Fido, Principles and Resources for Site Remediation and Landscape Design. This book contains a lot of non-native species, but it contains some native species in here as well. But it's really great. I keep it at my desk, and it's got all kinds of great ideas for how we can use phytoremediation and just simple landscape design, in our urban environments, suburban environments as well. Oh, there we go. If I move it, there we go. That helps.
We got a glimpse there.
Okay. Maybe we can put that up on the website, but I mean, all the other literature I have, is published by Springer, Taylor and Francis. I mean, there's the International Society for Phytoremediation. They have a great journal that they publish. I don't know that there's much else out there that's not an academic form.
Right.
So
you have to be persistent to find those academic studies now. It seems to take longer than it used to.
Right. And I've been writing articles for the Colorado Native Plant Society, for wild ones in our journal, doing a series of articles on the big four and how they can be used for various contaminants. So hopefully this will, help put out some information. Written some articles for the Arkansas Native Plant Society on species in Arkansas. That's just in our newsletter, and you can find these on the websites for these organizations. I haven't started writing a actual book yet, but it's in the back of my head. I don't know if I'll ever do that or not, but I just think that there needs to be a resource out there for just a simple landscaper, home gardener, or landscape architect even, that focuses specifically on native plants and phytoremediation.
Right.
And there's probably more knowledgeable people to do that than myself, to write a book like that.
Any final words of advice, encouragement, wisdom for us?
I think it's hopeful. We have all these people that are, becoming more aware. If we can see how much awareness has grown over the plight of pollinators and wildlife like monarchs and all the efforts that are being made to help with that. I think as native plant gardening and landscaping enthusiasts, it's in time, my hope is that we'll be just as knowledgeable as a group about which plants are good for which contaminants as we are about which plants are host plants for specific caterpillars. So
Right.
just it takes time,
or at least be able to look it up easily.
Exactly. Yeah. Now there is a great website I do want to refer people to, Stevie Fumilari. I'm assuming that's how you say that. She has a great database on our website, but if you go to STEVIE, Stevie, FAMULARI, Fumilari, that's her name, .net, then slash phytoremediation. She has a online database. And again, it's a collection of native and non-native species, but you can look through this database and look at by the contaminant or by the species. And for some of these plants, she has a picture of it. Others, and almost all of them, well, let's say all of them actually have the academic reference or publication that where you can look more into the studies that were conducted with that species and that and a particular contaminant. And for many of them, she also mentions the technique or different ways that they can be used. Kansas State University also has a really great database and access, Microsoft Access type database. I went to the website recently, and for some reason it wasn't on there any longer. But I do have a copy of that database, and you can look plants and search things by either plant or contaminant, and that was developed by the researchers at KSU. So there's information out there on the web. It's just not, you got to find it.
Right. Well, thanks so much, Eric.
Thank
blown
you.
away once again by your knowledge, and not just the breadth, but also the depth. And I appreciate your sharing that with wild ones and anyone else who is interested. And
Well, thank you. I appreciate the opportunity and appreciate people listening to me ramble. So,
okay, well, that's going to wrap it up for us, folks. Thanks for watching and have a great evening.